Hey everyone, I'm Alex, and with me as always is my curious and quick-witted co-host Rowan. We've got an absolutely fascinating journey ahead of us today.
Thanks, Alex. I'm particularly excited about this one. Just this morning I was asking my AI assistant to write a poem about my cat, which got me thinking about how far we've come from those early computer programs.
It's wild to think about, isn't it? We're diving into the incredible evolution of artificial intelligence. From its humble beginnings as theoretical concepts to becoming this transformative force that's reshaping how we live, work, and even create art.
The global AI market hit $387.45 billion in 2022, which is just wow. But how did we get here?
That's exactly what we're exploring today. We'll look at the brilliant minds who laid the foundations, like Alan Turing and John McCarthy, trace the major breakthroughs that changed everything, and examine where we're headed.
And we'll tackle some pretty big questions too, right? Like the ethical challenges and the whole debate around AI consciousness.
Absolutely. We'll explore how AI went from beating chess champions to generating art, and what that means for all of us. It's a story of innovation, surprise, and sometimes controversy, and I can't wait to share it with our listeners.
Well, I'm ready to learn. Let's dive in.
Let's start with one of the most fascinating figures in computing history, Alan Turing. Back in 1935, he proposed something revolutionary, the concept of a machine that could imitate any formal process of reasoning.
Wait, so he basically predicted computers as we know them today?
Exactly. The Turing machine, as it came to be known, laid the theoretical groundwork for everything we now call computation. But what's really incredible is that Turing went even further. He started asking the big questions like, can machines think?
That's still a pretty hot debate even today, isn't it?
It absolutely is, and that's why Turing's most famous contribution, the Turing test, is still so relevant. He proposed a practical way to measure machine intelligence. If a human judge couldn't tell whether they were talking to a machine or a person, the machine could be considered unintelligent.
That's fascinating and kind of eerily predictive of where we are now with chatbots and AI assistants.
What's even more remarkable is that Turing had this vision of what he called a child machine, a computer that could learn like an infant. He wrote about this in 1950, way before we had anything close to machine learning.
That's pretty mind-bending, to think someone was theorizing about machine learning before we even had proper computers.
Then there's John McCarthy, who really brought the whole field together. You know the term artificial intelligence that we use so casually now? He coined it in 1955.
No way, I had no idea it went back that far.
And in 1956, McCarthy organized what became known as the Dartmouth Conference. This was huge. It's basically considered the birthplace of AI as a formal field of study.
So what exactly happened at this conference?
Picture this. Some of the brightest minds in computing coming together to tackle this wild idea that machines could be made to simulate every aspect of learning or intelligence. McCarthy gathered people like Marvin Minsky, Alan Newell, and Herbert Simon.
Sounds like the Avengers of early computing.
That's actually a pretty good analogy, and McCarthy didn't stop there. He went on to develop Lisp in 1958, the first programming language specifically designed for AI research.
I've heard of Lisp. Isn't it still used in some AI research today?
It is. McCarthy also proposed something called the advice taker, a theoretical system that could learn from experience and use common sense reasoning. Sound familiar?
Like, basically every AI assistant we have now?
Exactly. These weren't just abstract theories, but they were the blueprint for what we're building today. Turing's vision of combining logic, probabilities, and learning is exactly how modern AI systems work.
It's incredible how these two could see so far ahead. I mean, they were basically describing things like GPT and modern AI decades before we had the technology to build them.
And that's what makes their contributions so remarkable. They weren't just solving the technical problems of their time. They were laying the theoretical foundations for technologies we're only just now figuring out how to build.
It really makes you wonder what they would think of where we are now.
I think they'd be amazed at how their theories have come to life, but probably not surprised by the basic direction. They saw the potential even when most people thought the idea of thinking machines was pure science fiction. You know, while those early pioneers laid the groundwork, there's another chapter to the story that really changed everything: the deep learning revolution of the 2010s.
Ah, yes, when AI suddenly got really good at things like recognizing images and understanding language, right?
Exactly. And a lot of this came down to some incredible technological breakthroughs, and one of the biggest game changers was actually something originally designed for video games: graphics processing units, or GPUs.
Wait, you're telling me the same thing that helps me play video games also powers AI?
That's right. GPUs turned out to be perfect for training neural networks. They could process huge amounts of data in parallel, making things possible that would have taken years with traditional computers.
So, how much faster are we talking about?
We're talking orders of magnitude faster. But it wasn't just about raw speed. The real breakthrough came in 2012 with something called AlexNet.
AlexNet. That was a neural network for computer vision, wasn't it?
Right on the money. Using GPUs, AlexNet achieved something remarkable in the ImageNet competition. It reduced the error rate in image recognition from 26% to 15%. A huge leap that nobody saw coming.
So that's why we suddenly got all these amazing image recognition applications?
Exactly, but there was another crucial development happening around the same time with something called long short-term memory networks, or LSTMs. These were absolutely revolutionary for processing sequential data.
Like text and speech?
Precisely. And get this, by 2019, the original paper about LSTMs became the most cited computer science paper from the previous millennium. That's how important this breakthrough was.
Wow. But there were some pretty impressive demonstrations of all this too, right? I remember something about a computer beating a Go champion.
That was AlphaGo in 2016, and it was a watershed moment. Using deep reinforcement learning, it defeated Lee Sedol, one of the world's best Go players, 4 games to 1.
But hadn't computers already beaten chess champions by then? What made this so special?
Go is vastly more complex than chess. There are more possible positions in Go than there are atoms in the universe. What made AlphaGo special was that it wasn't just calculating moves. It was showing real intuition and creativity.
And this was all happening while IBM's Watson was making waves too, right?
Right, Watson was a different kind of breakthrough. In 2011, it went on Jeopardy and beat the top human champions. It could process 500 gigabytes per second using 2,880 processor cores.
That's an incredible amount of computing power. But it needed it to understand all those tricky Jeopardy questions.
And what's fascinating is how all these different innovations, GPUs, neural networks, deep reinforcement learning, they all came together to create this perfect storm of AI advancement.
It's pretty amazing how fast things moved once all these pieces were in place.
That's right. And what's really interesting is how these breakthroughs built on each other. Each success opened up new possibilities, leading to more advanced applications.
And I guess that's how we ended up with things like DALL-E and ChatGPT?
Exactly. These modern systems are direct descendants of those breakthroughs in the 2010s. They're using the same fundamental technologies, just at a much larger scale.
It's incredible to think how far we've come in just over a decade.
And what's even more exciting is that we're still just scratching the surface of what's possible with these technologies. You know, there's another fascinating layer to this story we should explore. How major tech companies and research labs really transformed AI from academic theories into practical tools we use every day.
Like OpenAI and DeepMind, right? They've been making some pretty incredible headlines lately.
Exactly. These organizations have fundamentally changed how AI technology gets developed and commercialized. Take OpenAI, for instance. They've completely revolutionized natural language processing with their GPT series.
The impact has been huge. I read somewhere that over 1 million developers are now using OpenAI's technology through their APIs. That's pretty remarkable.
It really is. And what's particularly interesting is how they've democratized access to advanced AI. Instead of keeping everything in-house, they've made it possible for businesses of all sizes to integrate these powerful language models into their products.
So it's not just the big tech companies benefiting from this technology anymore?
Not at all. We're seeing AI being used in everything from small business customer service to healthcare applications. And speaking of healthcare, DeepMind made an absolutely incredible breakthrough with AlphaFold.
Oh yeah, that was the protein folding thing, wasn't it?
Right. They managed to solve a problem that had stumped scientists for decades. Being able to predict protein structures with such accuracy is transforming how we approach drug discovery and our understanding of diseases.
It's interesting how these companies seem to be taking different approaches. OpenAI focuses a lot on language and creative tools, while DeepMind tackles more scientific challenges.
That's a great observation. DeepMind has been pushing boundaries in areas like reinforcement learning and robotics. They're working on teaching robots to perform tasks with human-like dexterity.
But they're not just focusing on the technical side, are they? I've heard they put a lot of emphasis on AI safety and ethics.
That's right. Both organizations actually make responsible AI development a priority. It's not just about what AI can do, but how we can ensure it benefits society safely and ethically.
You mentioned APIs earlier. How has that changed things?
It's been a game changer for innovation. These cloud-based AI services mean businesses can rapidly test and deploy AI features without having to build everything from scratch. It's dramatically reduced both development time and costs.
So basically, they're not just creating the technology, they're building entire ecosystems around it.
Precisely. And this has had a ripple effect across the entire tech industry. Their research and open source contributions have inspired countless startups and influenced how other tech giants approach AI development.
It's pretty amazing how much influence these organizations have had in such a relatively short time.
And they keep pushing boundaries. DeepMind's been working on Gemini, which combines text, video, and audio in new ways. Meanwhile, OpenAI is expanding into multimodal AI, developing systems that can work with both text and images.
Sounds like they're both racing to create more versatile AI systems.
Yes, but interestingly, this competition has actually accelerated innovation across the entire field. Their breakthroughs often complement each other, pushing the boundaries of what's possible with AI.
And I guess that benefits everyone in the end?
Absolutely. These advances are driving automation in industries, improving decision-making processes, and enhancing user experiences across all sorts of digital platforms. It's really remarkable how their work has shaped the trajectory of AI on a global scale.
It's kind of exciting to think about what they might develop next.
Indeed. And what's particularly fascinating is how they're managing to turn theoretical concepts into practical tools that are already changing how we live and work. You know, with all these incredible advances in AI, we need to address some pretty significant ethical challenges that have emerged. These aren't just theoretical concerns anymore. They're real issues affecting people's lives right now.
I've been reading about some concerning cases like that facial recognition system that was showing serious bias against certain groups.
That's a perfect example. There have been multiple studies showing these systems are significantly less accurate for people of color and women. And when you consider these technologies are being used in law enforcement and security, well, the implications are serious.
It's pretty alarming when you think about it. Are there other examples of this kind of bias showing up?
Unfortunately, yes. Remember that hiring algorithm Amazon had to discontinue? It was systematically discriminating against women because it had been trained on historical data that reflected male-dominated hiring patterns.
Wow. So the AI was essentially perpetuating existing workplace inequalities?
Exactly. And here's what makes this particularly challenging. These biases often aren't immediately obvious. They can be buried deep in the training data or emerge in subtle ways that are hard to detect until the system is already in use.
And I guess that connects to another issue I've heard about, the whole black box problem.
Right on the money. Many of these AI systems, especially the more complex ones, make decisions in ways that even their creators can't fully explain. Take healthcare, for example. IBM Watson for oncology ran into serious issues because doctors couldn't understand or verify its treatment recommendations.
That sounds pretty dangerous, actually. How can we trust AI decisions if we can't understand how they're made?
That's the million-dollar question. And it gets even more complicated when we talk about privacy. These systems need massive amounts of data to function effectively, but that raises huge concerns about personal information and surveillance.
I remember reading about that fitness tracking app that accidentally revealed the locations of military bases.
That's a perfect example of unintended consequences. The system was just doing what it was designed to do, tracking exercise patterns, but when that data was aggregated and mapped, it revealed sensitive information that no one had anticipated.
So who's actually responsible when AI systems cause harm? The developers, the companies using them, the people who collected the training data?
That's one of the thorniest issues in AI ethics right now. When multiple parties are involved in developing and deploying these systems, accountability becomes incredibly complex, and our legal frameworks haven't really caught up yet.
Are governments starting to address these issues?
Yes, we're seeing more regulatory action. The European Union has been particularly proactive with their AI Act, classifying AI systems by risk level and imposing stricter requirements on high-risk applications.
But is regulation enough? I mean, these technologies are developing so quickly.
That's why many researchers are focusing on building ethical considerations into AI development from the ground up. They're working on methods to detect and mitigate bias, make systems more explainable, and ensure privacy protection isn't just an afterthought.
It sounds like we're in this race between developing powerful AI systems and figuring out how to use them responsibly.
That's a great way to put it. And what's particularly challenging is that we often don't recognize the ethical implications until after a system is deployed and problems start emerging.
Like that whole debate about AI-generated content and artistic copyright?
Exactly. No one really anticipated how AI art generators would impact creative professionals and the art market. Now we're having to grapple with questions about intellectual property, attribution, and fair compensation that we never had to consider before.
It really seems like every solution brings new challenges.
That's why it's so important that we're having these discussions now while these technologies are still evolving. The decisions we make today about AI ethics and governance will shape how these systems impact society for years to come. You know, with all our discussion about AI development and ethics, there's something really exciting happening that we haven't touched on yet. The way humans and AI are learning to work together in completely new ways.
I've heard some fascinating things about this. Doctors working with AI to spot things they might have missed, right?
Exactly. In fact, there's this really interesting study where radiologists working with AI caught significantly more potential issues than either the AI or the doctors working alone. It's not about replacing human expertise, it's about enhancing it.
So it's like having a really smart assistant who can process massive amounts of data but still needs your judgment?
That's a great way to put it. And what's particularly interesting is how this partnership model is evolving. Take financial advisors, for example. They're using AI to analyze market trends and risk factors, but the human advisor provides the crucial emotional intelligence and contextual understanding.
I guess computers might be great with numbers, but they're not so good at understanding why someone might need to save for their kid's college fund.
Precisely. And this is where something called explainable AI comes in. These are systems specifically designed to show their work, so to speak. They don't just give you an answer, they show you how they reached that conclusion.
That must make it easier for professionals to trust and verify what the AI is suggesting.
Absolutely, and it's leading to some really innovative approaches. For instance, some hospitals are using what they call a symbiotic mode, where AI systems are actually designed to recognize when they're uncertain and defer to human judgment.
Wait, so the AI knows when it doesn't know something?
In a way, yes. It's called the learning to defer paradigm. The system is trained to recognize situations where human expertise is crucial. It's like having a junior colleague who knows when to ask for help.
That's pretty sophisticated. But I imagine implementing these systems isn't always straightforward.
You're right. One of the biggest challenges is getting the balance right. Too much AI automation and you lose the human insight that's often crucial. Too little and you're not taking advantage of the AI's capabilities.
So how are organizations finding that sweet spot?
They're using something called dynamic task allocation. The AI system adjusts its level of autonomy based on the situation and the expertise available. It's like having a really smart autopilot that knows when the human pilot needs to take control.
And I guess different industries need different balances?
Exactly. In retail, for example, AI chatbots handle routine customer service queries but seamlessly transfer complex issues to human agents. In industrial settings, AI monitors equipment performance but alerts human technicians when it spots potential problems.
It sounds like we're moving away from this idea of AI versus humans and more toward AI plus humans.
That's spot on. The most successful implementations focus on complementary strengths. Humans provide creativity, emotional intelligence, and ethical judgment, while AI handles data analysis and pattern recognition.
You know, it's kind of reassuring. For a while there, it seemed like AI might just replace everyone.
The reality is turning out to be much more nuanced. We're seeing the emergence of new roles and skills specifically focused on human-AI collaboration. It's not about replacement, it's about augmentation.
Like having a really powerful tool that still needs a skilled operator?
Exactly. And what's particularly exciting is how this collaboration is enabling things that neither humans nor AI could achieve alone. We're seeing breakthroughs in drug discovery, climate modeling, and even creative fields that simply wouldn't be possible without this partnership approach.
It's pretty amazing to think about where this might lead.
And that's really the key point. The future of AI isn't about creating independent artificial minds. It's about developing better ways for humans and machines to work together, each bringing their unique strengths to the table. You know, Rowan, looking back at this incredible journey of AI from those early theoretical concepts to where we are now in 2025, I'm struck by how much has changed, and yet how prescient those early pioneers were.
It's pretty remarkable. They saw the potential even before we had the technology to make it happen. But I think what fascinates me most is how we're starting to find this balance between human and machine capabilities.
That's such an important point. We've moved past this notion of AI versus humans to something much more nuanced. It's about combining the analytical power of AI with human creativity and wisdom.
And we're seeing that play out across every sector, aren't we? From healthcare to creative industries, it's not about replacement, it's about enhancement.
Exactly. But what really excites me is how we're starting to tackle those big ethical challenges head-on. Companies and researchers are building responsibility into AI development from the ground up, not just as an afterthought.
Though we still have quite a way to go on that front, don't we?
We absolutely do. But that's what makes this field so fascinating. Every breakthrough brings new questions, new challenges, and new opportunities. The real task ahead isn't just advancing the technology, it's ensuring it serves human needs and values.
So, what's your take on where we're headed?
I think we're entering an era where the question isn't what AI can do, but what it should do. And that's a question that will require all of us, developers, users, and society as a whole, to help answer.